Great stuff. Hi, everyone. Good morning. Thanks to see you all. Thank you for making time to join our annual conference this year. For those of you who don't know me, I'm Rony Arafin. I'm the Chief Operating Officer of AphA. Thank you so much for joining and making time. So we'll make it start. We've got a really interesting and packed agenda with lots of interesting stuff for you today and tomorrow. So just to start off with a little bit of housekeeping and stuff, so you will know these things anyway, but just to remind you, so there are two different dial-in details for today and tomorrow. So you should be able to see that from the instructions being sent out to you already. But if you haven't, if you look at the Eventbrite, then you will find those links. And I'm sure Donna and others who are organizing this meeting, they will also post those links out in the chat for you to follow. So we have some breakout rooms, as you will see on the agenda. So this is the space for your networking as well. So please do move around the rooms. And actually, it's been spaced out in such a way that you can actually attend all three of those breakout rooms throughout today and tomorrow. And you will find those links on the chat window. So if you could please keep your microphones muted, unless obviously you are contributing and coming in. This will keep the background noise down. So just so you know, and you could probably see this already, it's being recorded and we will put it on our website and on our YouTube channel.
Galaxy A71.
Okay, some machine learning's happening in the background, but you know, this is an analytics conference, so just take it all in. So we will upload this on our YouTube channel, but the recording wouldn't include the breakout room. So I would really encourage you to go in and please enjoy those discussion sessions. And please do get involved and ask questions or comment using the Teams chat. So I just want to say my thanks to DataRobot for being our main sponsor. And also I'd like to thank Hugh Davies from Davies Furlow Consulting, InSource and Meditrans for supporting this event. And just 5 minutes around different stuff for AphA perspective. So hopefully you are starting to notice that we are doing quite a lot of stuff now as we are coming out from COVID. So I think AphA was set up with a great vision in mind, and we are really taking on that journey to move us from the concept to becoming a professional body for analysts. And that's really what we are working to represent you as analysts. So you will see there are some great works that are coming out in the last couple of months, competency framework that you will hear from me later on today, mentoring program. You will have seen lots of emails and news about that, so I would encourage you to get involved. And of course, there's lots of works happening in the background, and we are doing more around professional registration. So, and another thing is our partnership. So we became really close partners with a lot of the key analytical bodies in this area. So NHSX, NHS E&I, Strategy Unit, Health Economics Unit, NHSR Community, Health Foundation, HDI UK, HFMA, all of those people, they work really closely with AphA now, which is a fantastic achievement for us to be connected to all of these people and represent you as the professional body. So, you'll be very familiar with this. So analysis always kind of gets left on its side. So whenever work happens in an organization, we just get bring into the dialogue right at the end saying, I need this data. But we want to move on from that. We want analytics to be part of decision making. And the work you've been doing, throughout the COVID period is nothing short of extraordinary. So thank you for being part of AphA. We could shape the professional journey together. We as an AphA, we want to make sure that AphA stands up for you. And we can't do this alone, so we need you in this journey together. So do please get involved. I know we ask you to get involved in a lot of the things, but this is our vision to really do it collaboratively, do it together. And we want to make sure that we represent you wherever necessary and carry on representing our overall community and analysts in all disciplines. So today, and tomorrow there are various learning and development opportunities. Obviously, there's been set up fantastic range of speakers. There are lots of show and tell. There are discussion points. So I'd encourage you that to get involved. So it's a chance for you in a different way to network in this virtual environment. But do get involved, chat using the Teams functions, and I hope that you can celebrate, you can relax, and you can enjoy the next 2 days, seeing the interesting talk, show and tell, and the discussion opportunities. Because, you know, throughout the past probably 16 months, various reasons, I don't like to rehearse it, you know it more, the learning and development agenda has been pushed back a bit. So I think more than anything else, you deserve this space to be able to network and just listen to what else is going on. So anyway, thank you again for making time. So I will end there and I will go to our first speaker. So I'm delighted to invite our first speaker of the day. So I'll invite Dr. Sebastian Zeki, who is a consultant at Guy's and St Thomas Hospital. Sebastian, thank you for joining us.
Great. Well, thank you very much for inviting me to speak. It's always for me a great pleasure to speak to analysts, because I'm a big believer that analysts make probably the largest contribution to a lot of healthcare decisions, especially at my trust. So let me just. Okay, good. So I'm a gastroenterologist. Hopefully you can see the slide. I'm a gastroenterologist at Guy's and St Thomas's Hospital, and really I wanted to talk about firstly the kind of work that I've been doing, but also my experience, my real life experience about implementing it at Guy's and St Thomas's Hospital, and what we can learn, and certainly what I've learned about implementation. So the talk is really about developing a clinical informatics solution and how I did it from scratch, and particularly about its implementation. So I'm a gastroenterologist, so I spend a lot of time doing endoscopy and looking at things in the stomach and the esophagus and other places, and trying to figure out what it is. And sometimes I take biopsies and I look at these biopsies maybe 2 weeks later that hopefully give me an answer, and I try and match the two up. So we do a lot of endoscopy. At the Trust, we do about 20,000 endoscopies a year, and we have lots of questions that we need to answer. Things like, how many patients am I endoscoping with a specific disease condition? How good am I at endoscopy as measured by my diagnostic yield? When should we be following patients up with specific disease conditions, and so on? And so there are lots of conditions, lots of questions, I should say, that we ask of our data, which in general we are manually trawling through the data and answering these questions individually as individual endoscopists. So none of this is very reproducible, and it's obviously incredibly error prone. Just to add to that, we are increasingly being asked for national audits to contribute to things like the national endoscopy databases, and to give our managing bodies information about our performance in general at a clinical level. So it's done manually and not particularly reproducible, but it seemed to me that actually a lot of these questions we can fit into specific silos. So there are things we're interested in about procedure quality, such as how good am I at endoscopy, are we using too much sedation, and so on. There are questions about diagnostic yield, how many times am I picking up a certain condition? Am I doing enough biopsies to pick up that condition? There are things about surveillance. Are we tracking patients adequately who have a certain condition at time X? And are we booking them in for further endoscopies at the appropriate time, depending on their endoscopic or pathological examination? And then there are operational questions. How many people are we scoping? Are there ways of reconfiguring our services so that we can scope people at different time points? So if we just silo those questions into those 4 silos, actually a lot of that information, or a lot of those questions, can be answered simply by merging endoscopic data for an individual patient at an individual time point with the pathological data of any biopsies that were taken at that time point. So from that, by comparing pathology with endoscopy at a particular time point, you can get the questions answered about diagnostic yield. By comparing patients having consecutive endoscopies, you get information about surveillance metrics, and looking over all patients, you get information over patient flow. So this will of course be very familiar to lots of you. This is in my mind, it was simply a data merge. So what's the big deal? I just need to get some endoscopic data. I just need to get some pathology data. I need to just kind of stick them together, and then everything will drop out and I get to go home early. So it turns out that it's not really that straightforward at all, of course. The endoscopic data is just a load of text. It's in the best possible way, it's semi-structured, but a lot of the stuff that we input is just free text, and a lot of the stuff that is informative is in the free text mode. Pathology data is even less structured, so there are some headers, but actually a lot of the information is just captured in free text. And to add to that, there is a difference between the data, the endoscopy, and the data, the pathology. So performing a simple merge based on date and hospital number is never going to quite cut it. So then I took a step back and I thought to myself, is this actually doable? Because this falls within the domain really of natural language processing. So if you look at natural language processing, it tries to tackle complicated problems often related to trying to understand what's referencing what in sentences and trying to standardize text. So of course, if you take a text like Jane Austen's Pride and Prejudice, which I'll read out. So it seemed like willful ill nature or a voluntary penance, for on these occasions it was not merely a few formal inquiries and an awkward pause and then away, but he actually thought it was necessary to turn back. So by the time you got to the end of that sentence, you've probably forgotten what was at the beginning of that sentence. And that's a very complicated natural language problem. But it turns out that actually when we write endoscopic reports, we write a very bare bones version. So I would write something like, on the right, 2 centimeters height hernia, no evidence of dysplasia. So there's barely a verb in sight. And actually this makes a natural language processing problem a lot simpler. And so people have looked at this. If you look at the readability scores in a number of different domains within medicine, so there are a number of different readability metrics, but the one I've highlighted is called the Fleisch-Kincaid metric, and that looks at the average age when you strip out the grammar, when you strip out the complicated jargon, just look at the grammar, the average reading age of most reports in these different domains is around 11 or 12. So I thought, okay, that's great. This could be a lot simpler than I thought. And then again, knocked back by the fact that there are, because we write in essentially a kind of shorthand, there are spelling issues, there are variability of terms, there's often a strange use of punctuation and negative sentences, all of which need to be dealt with. So I thought, okay, fine, if I just break this down, I can attack each of these problems one by one. And so I started to build functions that try to extract the information by dealing with the natural language part of this. I removed negative sentences with a negex function. I tried to deal with variability of terms by replacing terms with a UMLS version, tackled spelling issues with simple string distances, and so on. And so I was able to get to a point where I had some kind of clean data. So I wrote all of this in R, which many of you will be familiar with, which has its own problems, which I'll come to in a minute. But it certainly, as a functional programming language, allows you to encapsulate various parts of your problem and process data often quite cleanly. And so I was at a point where I could extract information, fairly clean information, into separate columns for endoscopy reports and separate columns for pathology, and then get to a point where actually I could do a merge between individual endoscopy reports based on the date and their trust number with pathology and endoscopy. So I did the cleaning for both and managed to do the merge. And so I ended up with a bunch of functions, which was quite useful. So each of the problems I've talked about ended up as its own function, and so I kind of modularized that and called those the cleaning functions. But so once you got to that point, what can you actually extract from these reports? Well, it turns out actually even doing those kind of simple cleaning functions, you can extract quite a lot. So for example, I was able to extract the type of procedures that were being done from the free text, but more than that, I was able to understand the type of procedure and where it was being done geographically within either the upper gastrointestinal tract or the lower gastrointestinal tract. And that's a very powerful and very useful thing to do, because that then feeds into things like trying to automate OPCS4 codes and automate a number of different clinical audits. So I was very pleased with that, and obviously wanted to push the envelope. I tried to find out what else I could extract. Using some of the semi-structured nature of the text, which sounds simpler than it actually ended up being, but nevertheless I was able to extract things like the types of medications people were using, individual endoscopists that were performing the procedure, the type of events, and then with the pathology, things like the number of biopsies, the size of the biopsies, and the worst grade of pathology, which is really a lot of the information that we're interested in when we perform our manual audits. So I then encapsulated these functions in a kind of an extract module, and then really that's when the exciting stuff starts to happen, because you get to a point where you're now able to extract different disease types, because you've standardized the terminology with things like UMLS. You can start to extract the disease types and get information about them by cross-relating the endoscopy and the pathology data sets. So then I applied this to a number of different disease states, and again a further module was developed, which was the disease-specific extraction. And then the final piece really of the cake was to try and extract some of the operational information, which it was really the most straightforward part, because once you've got all the other parts in play, then extracting operational information is a lot more straightforward. R, of course, comes with a whole load of stuff built in, particularly the statistical analyses. So building this on top of what I'd already done was fairly straightforward. It's got some great data visualization tools. And then, of course, the nirvana, as far as I'm concerned, is automated report generation, which takes a whole load of work away from me and automates it. So having done all this, then the next step was really to do quality assurance. And I think when you build these kind of software tools, you have to do quality assurance on a number of different levels, all the way from the bottom, looking at how good is your negative sentence extraction, all the way to the top, which is looking at how good are you at picking up certain disease conditions. So I spent a lot of time doing this, publishing these kind of things in abstract form. This is an example of looking at the extraction of something called Barrett's esophagus, which is a pre-malignant condition of the esophagus, and looking at how good I was at extracting each part of the information that I need in order to make decisions. So this is historical now, and in fact the sensitivities and specificities I've translated into F1 and recall and precisions and accuracies, and they are improved. And I've done this in a number of different disease conditions. This is in the colon. And so I was quite pleased with that, and then I started to try and play around to see if there were other things that I could do. So just to give you an example of how these functions all fit together, because they are all separate functions, you can combine them in ways that would be useful for your particular use. So for example, you would run your data through the cleaning functions to do the basic cleaning. You would then run it through the functions that extract basic endoscopic information and pathology information, and then maybe you would run it through the Barrett's functions for that pre-malignant condition, and then visualize, and you would end up with something that looks like this. So this is, although it doesn't look wonderful, admittedly, it's actually a summary graph of something that is very complicated to extract. So it's looking at the shortfall in the number of biopsies that an expert endoscopist takes from a patient with Barrett's esophagus as compared to a non-expert endoscopist. So if you're trying to extract that kind of information in the ways we were doing previously was almost undoable. So this is the kind of thing that it started to automate. Again, using the functions to clean, extract the basic information, and do some data visualization would then allow us, as another example of extracting the diagnostic yield on a per endoscope basis, so that we can decide which of our endoscopes is performing well and maybe make a business case to replace them. And so there are lots of more interesting other things you can do. So the patient flow functions will give us interesting circus plots or Sankey diagrams to tell us about the patient flow. So that's all wonderful. I was feeling very pleased with myself. But of course, the real world intervenes. And the real world is a lot more complicated than that. So that was work that I'd done on example data sets. But there are lots of issues when it comes to implementation. So just to summarize, there are big issues with data access, and I will talk through that in a second, about how you actually access the data physically and where it is that you do your analysis for the data. There are big issues with the platforms that you do software development on within a trust. And particularly things like hardware resources, especially if you want to deal with very large data sets, and especially if you're starting to think about machine learning resources. There are lots of resources out there in the big wide world that we are simply unable to access on a basic level. And I will talk very briefly about things like GitHub and how that for me was a very difficult resource to access. And then there is the big problem, which is that of trying to convince others about the use of your tool, and then trying to actually get them to use it and the problems that happen there. So just starting really with how to get the data. So I started by understanding that I could do all this stuff, but the data I needed to acquire from 2 different departments. So we don't have a unified healthcare resource at the moment. We will soon, but I don't think it would be any easier. So I initially went to the endoscopy department and had to manually go down onto a computer which is shared with lots of other nurses and doctors, wait my turn in order to then access endoscopy software and then manually extract a spreadsheet of endoscopies that have been done, for example, in the previous 6 months. I would also have to ask pathology for a spreadsheet of pathology results that have been done in the previous 6 months. That involved me emailing pathology, usually via kind of a governance request, and then that being returned to me maybe a month, maybe 2 months later, by which time the endoscopy report was out of sync. So both of them are usually returned as Excel spreadsheets, and I know many people use Excel on a regular basis. For me, Excel is a great piece of software for what it's designed to do, which is really spreadsheeting. But in terms of versioning and reproducibility, it is not great. And this is a slide simply which I thought summarized things very nicely, which is in the financial sector. The road to Excel hell is paved with good intention. So 95% of firms use Excel, but then your boss comes along and gives you a few suggestions, and now your report is a lot more complicated. Then you disseminate the report and everybody has a look, and then they all have updates and tweaks, and then it takes ages to update all of that. Then you try using macros and link spreadsheets, and of course that's a disaster, as JP Morgan found out with a 6 billion hole in their bank account as a result of copy and pasting errors. You create lots of checks and balances to avoid errors. It takes ages to maintain, and then you basically try and disseminate amongst your big team, and the whole thing ends up being a huge headache, and it takes way too much time. That's really not where anybody wants to be. But that's where I was. So I was having these Excel spreadsheets emailed to me or manually acquired from a desktop down in the dungeon somewhere, and then I would have to email it to myself, and then on my trust computer start to try and clean the data. So that was no good. So the next thing I did was then really try and engage very heavily with clinical informatics, and ask them, is this something that they'd be able to do? It took a very long time to convince them, but essentially they were able, and it seemed quite straightforward to them, I think, to merge pathology information with endoscopy information via SQL, and then they would then email me the data. So that still required me to request the data, and then there being a big lag, and then the email will come through with the result. I did get them to show me the SQL that they actually used, and to me it looked incredibly complicated, but they seemed to think it was fairly straightforward. Nevertheless, the information was still being put on my trust computer, and I would still have to clean it on a trust computer. So that to me is far too many steps. They eventually gave me access to the remote desktop that they were using to perform the SQL, and I was able to perform it myself, so that I could then, without having to request the data, just run it whenever it was good for me. But I still had the problem of having to port it over to my trust computer and do the cleaning. I would say in all of this, the most important aspect of me trying to engage with the data has been really to engage with clinical analytics, because of course the analysts have all the tools, and they're at the forefront of the analytics, and so they're really the gatekeepers to getting all of this. But to convince the analysts took me a very long time, and in order to convince them, I had to do a lot of talks. I built a lot of things, user interfaces, to demonstrate to them that I really consider myself to have skills that, although may not be quite as good as an analyst, certainly the skills that allow me to do analytics, to answer some of my questions, and really to get to know the analytics department personally, rather than just via emails. And the other thing that I think is important in analytics is to find the person who makes decisions about what's the kind of projects that analysts want to engage with, because of course analytics is under a huge amount of stress at most times. So the timeline for all of this, so initially to go from just getting emailed from individual departments to engagement with clinical and informatics took about 3 years, and then for me to actually have access to the remote desktop myself took 5 years in total. So this is a huge amount of time, but nevertheless, the most important bit for me was being able to run my own analytics in hand with the access to the data. And of course, the question is, how do you do that? Do you run it in SQL? For me, SQL is a little bit too clunky, and I wanted to disengage the access from the analytics, the functions that access from the functions to do analytics. Excel I've already touched on, and the scripting languages that I was really most interested in and most impressed by were either R or Python. My background is really in R. I did a PhD that involves a lot of R, so I was much more comfortable with R. And I was very keen on R being installed. So I think just touch on R, and this probably also relates to Python as well. There are lots of issues with those kind of development languages that trusts raise. Analysts often don't have the permissions to download our studio onto their local machines. IT departments raise a lot of concerns about the security of open source. And there's also this question about how does the stuff that the platform that you want to develop on integrate with IT infrastructure. And I know NHSR is spending a lot of time trying to tackle these problems. I have to say, initially I had a problem with not being able to download RStudio. I spent a lot of time bouncing between IT departments, and then all of a sudden, for reasons that I don't quite understand, RStudio seemed to be something that we could all download onto trust computers. So I'd like to think that GSTT has been forward thinking, although I don't have any keys to how that particularly happened. So in the end, I was left with this setup. So I had a remote desktop, which I accessed via my trust computer. That allowed me into the clinical informatics environment, where I was able to run SQL and then run all of the R code within RStudio. So you can obviously run SQL within R. So I was very happy with that. So that for me is a one package that allows me to do everything from data access to analysis and report preparation. But of course, there are still problems, and one of the big problems I had was accessing developer resources. So one of the issues with NLP is that it is very hard. There's a lot of parts to it, as I've touched on, but there are a lot of resources out there where people have already figured out the problems and how to resolve them. And those developer resources really reside on things like GitHub, on GitLab and Bitbucket and all these other things. But if you try and access GitHub, certainly from my trust, and even on the clinical informatics resource, it can't be done, and it's simply seen as a resource that shouldn't be accessed. So that takes out a whole load of development resource that is inaccessible. It turns out that you can access it, and I was told by IT about how to access it using proxies, but I don't think that's something that is probably not recommended in general in different trusts, but also is not something that is within the technical ability of most people to do. Having said that, NHS Digital has a great GitHub site, so I'm not quite sure why there's a discrepancy between being able to access the developer resources for ourselves, whereas it is a resource that's used at a high level within the NHS. So in the end, I was quite pleased that I was able to manage this Endeminer. It's called the Endeminer package. It's available as an open source thing, and it works very nicely with some of the metrics that I've demonstrated. But the big issue really is with engagement. You have to be able to, it's all very well me running this stuff and doing it myself and being pleased with myself, but you have to be able to engage. And the three, I make no apologies for simplifying the groups that really I spent a lot of time engaging with. So the first group is clinicians, managers, obviously, and I'm really talking about departmental managers, and the analytics. So just to summarize the kind of behaviors that I encountered, clinicians and managers won't code. So there's no point trying to come up with informatics solutions that involve any kind of code, and managers in general at departmental level aren't interested in learning how to code in order to do the analytics, because it's considered to be something that should be done by analysts. Clinicians are great at clicking buttons, but none of us want to click lots of buttons. So if you're going to create a user interface, make it simple. Managers probably spend a bit more time with these kind of user interfaces, as do analysts. Clinicians like to solve problems, but they won't be solving any of your problems to do with implementation of software. They just want to solve, I say they, we want to solve problems related to patients. Again, at the management level, there won't be much help in terms of trying to solve how to implement software, but the analysts, as ever, are the most helpful. Clinicians in general want to have better output, and they want to have quicker output. And overall, they just want to have output without having to put any particular effort into gaining that output. And overall, I'd say my experience of my clinical colleagues is that they don't particularly want to help implement software, and neither do managers, whereas that's a different case with the analysts. However, whether we like it or not, the people really that you have to engage with are clinicians, because we are the people dealing with end users, we deal with the patients, and we are the people who put the information in. So it has to be easy to use, and we have to be engaged really with the output. So the next question I had is, how do you engage a clinician? And you'd think maybe I had the answers to this question, being a clinician myself, but the answer is no. So my first approach was show them the anatomy of your software and how it works, and they'll be fascinated by it. So I went about writing websites that show how Endeminer worked, showing off its innards, writing tutorials, giving explanations of the functions, writing demos, which could be run with a couple of lines of code. I put it all up on GitHub so anyone could contribute. I set up a British Society of Gastroenterology data analytics group so that we could have higher level engagement from clinicians who make decisions on a national level, and of course the inevitable Twitter account so that people could comment as and when. Just satisfy the academic clinicians, I also published it in the Journal of Open Source Software, which I'd recommend to anyone who wants to publish software, and plenty of abstracts really validating different disease processes and how it all works. And I thought to myself that was probably enough. I even got a grant from the Health Foundation to try and do various different solutions to problems that we had, and I thought that was enough. And of course, this I presented all of this to the clinicians, and this is an example of the worst slide you could probably show any kind of clinical group. This is, I thought, a nice slide, but it's a slide showing very simply how functions or functional programming is put together along a pipeline so that you can rearrange and use them to whatever benefit you like. But the inevitable result was this. So everybody leaves the room without wanting to have much more to do with it. So how else do you engage a clinician? Well, the other thing I thought about doing was to create an interface, which I went ahead and did. So a very simple interface which allows you to upload your two data sets, merge them, and then map your terms. And that's all you have to do. And of course, once you've done that, everything is done for you. It'll separate all of your information into different disease processes. It'll give you lovely heat maps about what you're doing. It'll allow you to drill down into individual patient level information for polyps, for different other diseases. You can drag and drop information according to your columns so that you can get customized heat maps and drag and drop columns, and it'll even produce automated reports based on your performance. So I thought this was great, and this would engage clinicians, because basically what I was saying is that give me your text, you don't have to do anything, and I will give you all of this visualization back. But again, the answer was, okay, fine, and so what? We've seen lots of clinical informatics, big deal. So then I thought, fine, all right, so I've got not much left in my armamentarium. What about I create a specific problem domain, which I know causes a lot of heartache among clinicians, and I demonstrate to them that I can remove this work burden from them. So in the last few slides, what I did was apply Endominer to a condition called Barrett's esophagus, which is a premalignant condition of the esophagus for which patients undergo regular surveillance endoscopies. It's basically not done very well, and that's partly because we have to search for different information pieces in different areas and put them all together based on previous endoscopies. So it's well known to not be done very well, and this is a national and an international problem. And part of the other problem is that you have to maintain surveillance databases apart from the electronic health record, which is burdensome. So the information comes from endoscopy, so you have to extract these two bits of information, which are usually interpreted from the text. Again, you have to interpret the pathology text, and then you have to put them together on this complicated kind of throughput, and that's probably why it's not done very well. So I applied Endominer to this problem and published it. And then approached my trust to say, look, I can take all of the Barrett's esophagus patients. I can demonstrate that we are not doing it very well, and that we're either endoscoping patients too early, too late, or not following them up at all. And I can show you a cost saving using Endominer. And so that's what I presented to the trust board, and it's only since doing that that I've had interest from the South East London Cancer Alliance in order to try and scale this up trust-wide and hopefully regionally. So just in my final two slides, there are lots of other points which I wouldn't possibly have the time to cover, but there are issues about open sourcing in-house development and licensing of in-house development, how you build a team around your project, particularly with external contractors, how we share solutions within the NHS, and I know there have been some very innovative solutions to try and deal with that, but that's still an issue. The intellectual property of the code that analysts produce, and how we disseminate code and solutions NHS-wide. And then the other big question for me is what happens to our in-house analytics in the era of all-encompassing EHRs, and I think there's going to be some conflict there, and how that is resolved. So in summary, my learning points are definitely engage with clinical informatics and prove to them that you can do some of the analytics yourself. Get your development infrastructure in place, probably in the way that I've done, and in a way that can be trusted, and develop software initially that can answer lots of problems. But when you try and engage with people, try and answer a particular problem and demonstrate how that can be done, and then you will be allowed to scale up to tackle other problems. So thanks very much for your time. I hope that was a kind of a nice insight into the issues that I've been having, and hopefully lots of food for discussion. Thank you.
Sebastian, thank you very much. That was fascinating to listen to, and you've done some fantastic work. You can probably see on the screen the amount of virtual clapping hands are coming up. So that's really useful. We've got some time for a couple of questions. So there are obviously some links that you put in, and if you're happy, obviously I know we will share these slides.
Of course,
so,
yeah.
I don't know whether you want to close sharing the screen and we bring people into the video chat, if that's possible, please. Thank you very much. But thank you again. So there were some comments. I'm sure you couldn't see that on the chat, but some people were saying, particularly from Rebecca, that one of your slides can we make this as a NHS nationwide screensaver.
Right.
Lots of people like that, so it's brilliant. One of our branch leads, Ruth, have asked some question. Ruth, do you want to come in? I don't know if you are in here and ask the question, or.
Thanks, Rony. That was brilliant. Thanks so much, Sebastian. Really, really interesting and completely echoes some of the experiences we've had. I work at Imperial, but I'm also the AphA branch lead for London. So my question is, how far could we take this tool? I'm searching for the holy grail of auto coding, using natural language processing to be able to clinically code spells in hospitals, and I just wondered whether you'd attempted to use this solution for auto coding endoscopies, and what kind of accuracy you might have achieved if you have explored that route.
So that's a great question. So actually the next chapter in what I've been doing is exactly that. So when you start to, I suppose, approach machine learning, there's obviously a lot that you can do in order to categorize text. But actually a lot of the background work is in making sure that the data that you input into any kind of machine learning model is very clean. So really I see this tool as a cleaning tool. It cleans up data in order for it to then further be processed. So I have done some machine learning. It's a kind of transfer learning, which has allowed me to categorize aspects of endoscopy as applied to specific diseases, and one of my areas is Barrett's esophagus, and that's allowed me with very good accuracy to extract things like the length of the disease segment and the worst grade of pathology. And I'm very happy to share with you. I'd be happy to share with you the recall and the F1 scores for those particular domains. So I've only just started doing that, and I'm hoping to apply that to other disease processes. But essentially the way I've done it is to use Endominer to categorize the most of the text, then to manually validate it, and then to feed that into the machine language model to give me accurate categorization. So if you like, it's a kind of a feedback of improvement of categorization, which the machine learning does the final bit for the particularly complicated reports, and that's something that I'm hoping to pursue. So those annotations, once I've finished, hopefully will be made available. So the weights that give those activations will hopefully be made available more generally. And the other thing I should mention is that we have just started using something called CogStack at GSTT, which will also help to perform annotations in a more general sense, not just for endoscopy, but for other disease areas.
Thank you. Thank you very much. Thank you both. There's one more question, Sebastian. It's from Heather, actually, one of our other branch leads from Southwest. Heather, do you want to come in?
Yeah. So my question really was, I loved your presentation. I loved the fact that clinicians and analysts can work together to try and generate a solution that will actually improve patient outcomes. But I was just thinking, is there a role to play with the commissioners? So the integrated care services, care systems, sorry, so they're a group of people, providers, commissioners who come together, and maybe if you can get engagement from them, they can influence each of the providers within that area to perhaps adopt some of these solutions.
Yeah, so I think that chimes very well with the engagement side of things. I think one of the mistakes I made initially was, and I don't want this to sound too bad, but I engaged at a level which was not high enough. Actually, when you want to implement or when you want to develop something that you think might have generalizable use, then the engagement really should be past your own department, and you should be proposing these kind of things at a level of supra-departmental influence. The problem I had, of course, was that I needed to demonstrate that this was a doable concept. Natural language processing or programming is not something that's familiar to a lot of people. There's a lot of resistance in general to doing coding with healthcare data at a departmental level, because it's all kind of newfangled stuff in people's minds. So I have to demonstrate, and this goes for all clinicians. You have to demonstrate that you are an analyst before you're going to get any engagement at a higher level. and in fact, analysts won't take you seriously if you're just an irritating clinician that's just turning up with a demand for data, which I think is probably a lot of people's experience. So if you like, I suppose I turned it a little bit on its head in that instead of I kind of went to the analysts with a bit of a begging bowl to say, look, please take me seriously. And it's only then when doors start to open and you start to understand, like for example, by presenting here, that there are other opportunities at a higher level. But I suppose one of the big questions is how does a clinician with an idea understand that's a pathway?
Thank you. I think we've got time for possibly one more question. Martin, can I please bring you in? You had your hands up.
Oh, sorry. Yeah, I put my hand down because I think you sort of answered my question anyway, Sebastian, earlier. But one thing we found in the work we've done is if you can get people on board, the key users and so on board in terms of the project development stage, you're much more likely to get their engagement further on in terms of usage and sort of promotion, if you like, of a tool like this. I mean, I think it's absolutely fantastic what you've done. The other thing I was going to say is I've been supervising a PhD student who's doing exactly this sort of thing, a guy called Rob Challen. So I might want to put you in touch with him because I'm sure there's a lot of shared interest there.
No, absolutely do. But the one thing as a parting comment I'd say is that you've highlighted the paradox really, which is to engage users. You have to show an end product to a certain degree, but to get to the end product, you have to develop it. So trying to engage end users at a development stage was not going to work. And of course, a lot of people that I engage with are not very forgiving of software that doesn't quite work. So if you're showing the beta version, they will point out the minute error that and point that out as a big problem, forgetting the huge amount of work that you've automated for them. So that kind of that's the paradox that I've really had at the development stage.
Yeah, and you clearly done a lot of work in assessing needs as well, and liaise with colleagues in order to assess what sort of things they wanted. I think that's often the important thing, is that you're responding to specified needs rather than just thinking what people like and want. And it's
absolutely
excellent work. I mean, I thought the focus you put on implementation was particularly useful. Actually, it's often something the academics. I'm a researcher myself. We don't focus on enough, which is how we make things useful for people.
Absolutely.
Thank you.
Sebastian, thank you very much. This was an amazing piece of work, and thank you for coming and sharing this with a lot of analysts. We've got a lot of people watching this, so thank you again for your time. So can we please put our hands together virtually for Sebastian to really show that and share his work with us. Thank you very much for joining us, Sebastian, again.
Thanks.
Take care, and I'm sure we'll be speaking with you soon and sending many more questions on your way. Thank you very much. Okay, so the next part of the agenda is I would like to invite Lucas Inning from Data Robot. So thank you to Data Robot once again for sponsoring, being our main sponsor for this event. So Lucas is going to share with us a live demo of the Data Robot tool, which hopefully you'll find it very interesting. So can I please introduce you to Lucas Inning? Lucas, please come in.
Yes, hello, and thank you very much for the warm welcome. And thank you, Dr. Sebastian, for that really interesting talk as well. I just have to say this vibes a lot with me. A lot of the same challenges I think I come across, especially the part about working closely together, right, between analysts, between kind of the subject matter experts, etc. It is so important to get anything done, right, and out into the wild. So without further ado, let me quickly introduce myself, and then I'm going to show you a few slides, and then I'm going to run through a demonstration. I think I have half an hour, so let's see if I get through with everything. I want to leave some room for question in the end, but I will also be part of some of the breakout sessions throughout the day. So if you have further questions, then we can discuss more details then. So let me first see if I can share my screen. There we go. And there we go. And there we go. And there we go. Right. So I hope everybody can see that. So yeah, my name is Lukas Innig. I'm working as a data scientist at DataRobot. I'm with the company now since 3.5 years. My background is actually in retail. I'm not a healthcare expert at all, but I have done a lot of work on data science and getting data science project, predictive analytics projects into production, right? Delivering value. And we currently already work with some NHS teams, so mainly in university hospitals of Morecambe Bay and then also in Greater Manchester. We have some use cases in production already. There's ongoing use cases that are being developed together with the teams there, right? So I only serve as a, I guess, consultant in a way, right? But it's more to guide through how to use the platform. All of the work is really done by the team within these areas. And that is for me very important, right? We don't want to keep the knowledge to ourselves. We really want to help enable the different teams, analysts, data scientists to do the work themselves. So I just want to quickly run through some of the slides. And I'm actually going to show you an example use case today, which is all about readmission. So basically, this is a very common problem in healthcare. We have patients in our hospitals. The question is, if we release those patients, will they come back for the same illness or not, right? And our hope is, of course, we could reduce that because that obviously increases the quality of care, but also decreases costs significantly. That is only an example, of course, right? We are working on various other use cases on population health, operational efficiency, these kind of things. So just very quickly, I realize this is a very technical and advanced audience, but just so we are all on the same page, just a very quick run through what machine learning actually tries to do, right? It's all about finding patterns in historical data and then using those patterns to help predict the future. And it's really hard to predict the future. So very, very quick run through, right? A typical machine learning use case might be, can I predict the value of a house? And maybe I have data like this. I have the square footage of my house. I have the sales price, and I can then plot one against the other. And this might look something like this, right? So every dot here is one property. And now I can start build my model here, right? And my model might be just this line. You can tell from the fact that it's bendy, that it's a very advanced model. But that's basically how this works, right? This is something you could do even in Excel. And now if we are asked to predict the price of a new property, all we have to do is look up the square footage that our new property has. We go to see what the model is telling us about this, and then we see, hey, that's the sale price, right? Now, in this instance, of course, we only look at one input feature, as we call it. But, you know, the reality is much more difficult typically, right? We have many, many more input variables, descriptive features, etc., that can potentially help us get a more accurate prediction. And that's when machine learning becomes relevant, when we need to make sense of all of this together, really find those complex patterns that are in the data to make a more accurate prediction. Right, and now, of course, in order to do that, typically you need very good analysts, people who have some experience in coding, in machine learning, mathematicians, etc. But there's kind of a limited supply to that because they typically just flee towards all of the big banks in Canary Wharf rather than spending their time in one of the NHS trusts, for example, in Northern England. And we know this is a problem. The demand is increasing, the available data is increasing. So what can we do here? We can try to help by automating certain aspects, but not every single aspect, right? So the domain expertise is very much required in order to use the DataRobot platform, and I hope this will become clear. But certain other tasks that you would typically have to do can be very much automated and sped up. So the DataRobot platform consists basically of 3 different parts. We try to cover the whole journey from the raw input data to the actual outcomes, the predictions that then help us deliver value. So we cover things like data preparation. So there's a visual data prep tool that we have as part of the platform. We also cover automated machine learning, of course. Time series is more a special type of model. So for example, we have a model in production right now that tries to predict how many patients will come through the A&E unit in a specific hospital in the next 24 hours. And that can, of course, be used to then better plan ahead. But then most importantly, almost, we have this operationalization piece. So getting machine learning models, once they are being created, into production and keeping them in production, that is a big challenge with even the best data science teams I talk to. They will struggle to make the gap here. So this is why we focused a lot on this part, and we have the ability to get models into production fairly easy. And we also support other models, right? So if, for example, there would be an R model, which has been created by Dr. Sebastian, for example, we can also get that into the same platform. So we have it running there, have API integrations, get it into different tools and platforms. And then I guess one of the parts that I mentioned earlier is we want to enable not only the data scientists. So the users of the platform are, some are data scientists, but some are your analysts, people who are kind of close to the data, but not necessarily have that machine learning background, right? So they are also able to use the platform with a bit of training, right? It's like with any tool, you don't become a data scientist from one day to the other, but with there's a bit of a learning curve, but then you will be able to do these analyses yourself. So moving on, there's a few different kind of types of machine learning problems that we can solve. And these are kind of your kind of classical classification and regression type use cases. So classification is all about answering yes/no questions. And just to give you an example, we are currently working on a waiting list prioritization use case. So the question here is, which of our patients currently on the waiting list have a very high risk of being emergency admitted, right? And we can look at historical data. We know patient has been admitted, yes or no. So this basically is a classification problem. And then on the regression side, this would then be something, for example, length of stay in your hospital, right? How long is my patient going to stay at time of admission? And then, as I mentioned, we have time series modeling. We also have visual AI use cases. So this would be looking at images. In this instance here, you see kind of skin lesion data, but there's, of course, a wide range of other problems that you can find there. Location AI, making use of the geographical location potentially patients are located. And then we also have unsupervised modeling, which is all about trying to find outliers, different patterns in our data that we haven't seen before, right? Just to maybe point our attentions towards these and investigate that a bit more. If we had an automated system that can just tell us, like, here's something that you should look at. And now I'm going to do a demo. So let's see, where do I start? I will actually start at the end, right? Let's say I have this is a Power BI dashboard, but this dashboard is fed with predictions made in Data Robot, right? And the idea here is we are going to pretend we are in a hospital. We may be the head nurse within a hospital, and we look at, we are in the nurse's station. And now the question is going to be, which of the patients currently in our different rooms here have a very high risk of being readmitted if we were to release them today? Right, and we can see there's in room 105, there's a patient with a 21% risk. But here in room 101, there's a patient with a 61.8% risk, right? So this is much higher. And now I can maybe select this patient and look at what are the different reasons for why the prediction is so high. It looks like they have an emergency/trauma specialty flex here, and they had a few emergency room visits in the last 12 months already, which leads the model to believe that, oh yeah, the risk is higher. Now, you don't have to take this as at face value, right? This is we call it augmented intelligence. So you would say this is probably a patient you should look at closer, right? This one more than this one if you had to prioritize, but still the decision is up to, of course, the attending doctor. So that is the problem, but basically this is the solution, right? And now the question is, how do we get there, right? And that's what I want to run through today by using Data Robot. So this is our Data Robot platform here, and as we can see, the thing we really need is some data here. So we have different ways of getting data into Data Robot. A lot of the teams I currently work with actually use Snowflake, and that's of course one of the ways we can grab data very easily, but there's lots of different connectors, or I can upload a file from my local laptop, right? So this is, I actually have the data here in Excel, which I'm going to show you very quickly. So the data, how this looks like, and please keep in mind, this is not real data. So it might not look 100% like you're expecting it to look, but I hope it tells a story, right? So here we see these are historic patient spells in a hospital. So we see every row is one patient in a hospital, and we see all of the different features or parameters of our patient, right? So we see the gender, the age. We saw how many days in hospital they've been. We see kind of the number of lab procedures here. How many times have they been to the hospital before, right? So there's all this kind of information here. But we also have a patient ID. And now this is a crucial point. Typically, your data doesn't really look always nice in one clean table. I'm pretty sure you would agree with that. It's not always the case that we can just get started, right? So what I also have is I have some lookups here, right? I see, for example, some diagnosis codes. So these are ICD-9 codes, I believe, a bit outdated, but every patient can have a diagnosis, and they can potentially have more than only one diagnosis, right? So they can have a primary, secondary, tertiary diagnosis. And we see here a lookup between the patient and our diagnosis. Now, what else have we got? We have medication information, right? So again, each patient might have 0 to many meds they are on, and the meds have a status. And yeah, since these are all diabetes patients, this is of course things like insulin, metformin, etc. The diagnosis also have a lookup, by the way, so we can have a look at the code, and then we get a description of what that actually means. Now, one thing I forgot to tell you about is, since this is all historical data, we actually know about if these patients have been readmitted in the past, right? So for every patient here, we have this, we call the target, the thing we want to predict. So we know that historically, this patient has not been readmitted, but this patient has been readmitted. And now the question is, can we find the patterns in all of this data? And hopefully we can also take into account all of those other data sets that I mentioned. So now I'm going to jump into the platform. I have uploaded this data already to my catalog. I'm on the wrong, one sec, I need to go to the other cloud. So there we go. So I have uploaded my data already to the catalog, and now I search for my readmission data, and I see here, these are the 4 data sets, right? Readmissions, this is the main data set, and then the medications, diagnosis, and then the lookup. So I'm going to take this data and create a project. Now, the first thing that typically happens when you create a project in Data Robot is that we look through all of the different columns in our data set and try to figure out what is actually in here, right? Are these numbers? Are these dates? Is it maybe text? And as I said, we also support things like images or geodata, right? So there could be an image here of the patient. I don't know how much sense this makes in this case. So we see all of the different columns in our Excel spreadsheet, and here now we see the variable type, as we call it, has been detected as categorical, numeric, etc. I can have a very quick glance on the distribution here, just to make sure that everything looks okay. I get some warnings as well if there are, for example, outliers in my data, which in this case I can ignore because they're fine, but maybe you want to double check those. And you also get information about the missing values, right? Our data is, not of perfect quality, as we know. There will always be missing values. The good thing is we can treat that and kind of smooth it over. So what what is next? The next step is I need to tell DataRobot what I want to predict, which is of course my readmitted flag, which has these two options, yes or no. And now I want to add those secondary data sets. So let me do that here. I'm going to say add data sets and select the ones that I want out of my catalog. I'm going to say readmission. And I'm going to add my medication data, my diagnosis data, and then my lookup as well. So now I need to, this is where, again, my input is required. I need to tell DataRobot how these data sets actually relate to each other. So in this case, I know that my diagnosis join to my patients via the patient ID. That makes total sense. And I also know that my medication join to my patients over on the patient ID. And then my diagnosis lookup table, that of course joins to my diagnosis table. And since the name isn't matching, I actually have to tell it the code here is the diagnosis code there. There we go. So now I'm done with this. This is a fairly simple setup, but as you can imagine, this can be as complex as you want it to be, right? So these secondary tables, they can be, for example, historic hospital spells with all of the information that is part of that, right? So all of the diagnosis, all of the length of stays and etc. procedures, and you can have more than only one of those per patient, right? So that is something that is very, very helpful currently in this use case that we are doing on the what's it called, waiting list prioritization. So I'm happy with this. I'm going to say continue. And now I'm basically done, right? I can now say, excellent, happy with all of the setup, hit the big start button. But now, of course, if you are a data scientist, right? If you do want to know a bit more, hey, what is actually going on behind the scenes here? Maybe I don't trust that this autopilot is doing the right thing. You can always go and have a look behind the scenes, right? You can have a check on how do we partition the data. Maybe you want to do some constraints. Maybe you want to check bias and fairness, right? That is something that is becoming more and more important, right? That our the models, the machine learning models that we are putting into production are not accidentally kind of reinforcing some biases that we have observed in the past. So this is why we have built this in, and here we can say there's certain protected features that I really want to care about. So this is the whole philosophy of DataRobot, really, to make sure that everything is as automated as possible, but at the same time give you the ability to see what is going on first, and then second, also adjust these things, right, and change settings if you wanted to. And now, since there seems to be a big R audience, we do have, let me just quickly go there, we do have packages for both R and for Python, which you can actually use to remote control this user interface, right? So you don't have to use the user interface. You can actually go in here and train models yourself from R. But of course, it would still make use of the same framework. So I'm going to show you the user interface. So with that, I'm ready to hit the big start button. And now what is happening is that we perform quite a few different steps. And this is where the automation really kicks in. Right, so we now say we have our primary table. That's cool. But we also want to ensure we take into account all of the secondary information that we joined onto this table, right? So we see how there's a few steps about that, loading the secondary data sets in the first place, and then discovering new features that are hopefully valuable, selecting those, generating a bunch of new, hopefully predictive features. And what we do here is we actually tend to create more features than are necessary, because we can always later filter them out again, right? And that's the idea here, that automation can help us to discover more by just using, of course, CPU power time rather than human time or analyst time to come up with ideas. And then afterwards, you can have a look at that and see, well, what actually did work? Maybe I should focus on certain things rather than other things. There's a few other steps that are happening here. This is the team windows in the way. I don't know how to get rid of that. Maybe like this, yeah. Oh. Okay. A few more steps happening here. And I think the most important one is the last, which is generating blueprints. since we don't really control the data that is being fed into Data Robot, every data set is very different, right? We have to test various different machine learning approaches. And so this is what we do here. We don't only run 1 or 2 different machine learning models. We actually run between 10 and 50, depending on the data set. And then we validate them all and check which one actually works best on this data set. And then finally, we recommend the one that achieved the highest accuracy. Okay, so this is going on for a little while here. I'm going to wait for this to happen. Let me quickly think if there's anything else I forgot to mention. No, maybe there's a good time for question right here, if there's one. No questions? Okay.
Thanks, Lucas. There is actually a question in the chat about whether you have any NHS use cases. So I know you mentioned the work you've done in Greater Manchester and Morecambe Bay in your opening presentation. So maybe give a bit of a flavour of what you've done with those organisations. That would be helpful.
Yeah, perfect. I can do that. So let's see. We have use cases on, for example, breach prediction. So the question here is, if a patient comes through our A&E doors, right, and they are then being triaged, the question is, what's the likelihood that this patient is going to be staying there for more than 4 hours, right, having to wait long? And the sooner we can make this prediction, the sooner we can then go a little bit further in our, I call it the supply chain, and for example, reroute ambulances that are currently on the way to hospital A to then go to hospital B instead, right? If we know that in hospital A currently there's a high chance that many patients are going to breach, since they might have some more complex whatever they have, right, conditions. So then we can kind of preemptively say ambulances go to a different hospital. Right. So that's one use case. I mentioned already the demand forecasting for A&E units. So this is a 24 hours ahead use prediction for different types of A&E units, the major and the minors in different hospitals, just to know a little bit further ahead if you expect a spike to happen. On the population side, we are currently looking at predicting undiagnosed conditions. So here the question is going to be, for a specific condition like we focused on hypertension, but there's of course more that you can think about. What's the likelihood that there's going to be an emergency admission for anyone? And then you can basically make prediction on your whole population, right? And then, for example, go to the GP, tell them, hey, this patient of yours has a high likelihood, maybe you should do a check-in or something. So that's another example. Then we have some planned as well, which is on now very kind of timely one is on vaccine take up, right? Can we understand what are the main drivers for a patient not to take their vaccine? Since the relationships are most likely going to be fairly complex, right? There's going to be interactions between all sorts of different things. Just looking at simple strata might not be sufficient. So that is something we have planned. And then I also talked about the reprioritization use case, right? Where we look at what's the risk of a patient currently on our waiting list to have an unexpected emergency admission, and therefore we might want to prioritize them a little bit before, right? Because those waiting lists are, have grown a lot during the COVID time. So this is just a few examples here, right? I mean, there's of course more that is possible and more that is planned, but I think these are some of the highlights. Yeah. All right, so I'm going to move on now with the presentation. The first models are running here, as you can see. There is, various different models as well. So we make use of different kind of libraries here. So we use Python models, we have R models, we have some of our own proprietary models, and they are now all being trained and validated against this data. Now, this process is going to take a while, which is why I'm going to skip over to a finished version of this whole thing. And as you can see here, we this is the same setup, right, with the different kind of tables that we have. And now just a very quick glance at the data that has been created here. We know that we've started out with only, I believe, 21 input features, but we end up with 44. And here we see now what kind of features have been created, like the descriptions of our diagnoses have been tokenized. We even look at kind of combinations of different tokens, maybe words together. What's the most frequent diagnosis that I see in my data, etc., etc. And the same is true for, of course, our medication, right? Which medication have patients been on? So these are just automatically created input features. And now after we run our modeling step here, we are being presented with a long list of different models, right? So all of these models have been trained, and I can now see which model actually performed best out of all of these, which in this case is an XGBoost model. But of course, there's other on the leaderboard like a SVM classifier, generalized model, etc. Now, of course, just knowing which model works well is typically not enough, right? We also want to understand why. So let me tell you a bit about that. With every single model, I have the option to open these up, and we can now see what actually happens here, right? What are we doing in terms of the machine learning flow? So we see how are our different types of variables being treated. We see the numeric variables. We do some missing value imputation, and then it goes into this actual machine learning algorithm itself. Now, if we want to know more about any of these steps, it is fully documented. I can hit these boxes, go to the documentation, and read up on this XGBoost model here, get a bit of a high-level description, and then I also see some of the parameters. So those data scientists amongst you will of course know that it is important to tune some of the models, right, and make sure we choose the right number of trees for a random forest model, for example. So all of these parameters, they are being automatically tuned by DataRobot, but nothing is stopping you from just going in there and doing your own tuning if you wanted to, right? So this is again about my previous point. We automate as much as possible, but we don't want to take anything away from you as well. Further things I of course want to look at is now, well, how well does my model really perform? And for this we have various metrics here. Some of these metrics you will most likely be familiar with, things like accuracy, maybe F1 score, and then of course our confusion matrix. So how many predictions did we get correct? These are the true negatives and the true positives. And how many predictions did we get wrong, right? False positives and false negatives. And now, of course, it really depends on what we are trying to predict here, how we can interpret these numbers. A false positive in this instance would be the model thinks our patient is going to be readmitted, but in reality they did not, right? So what is the cost? What's the effect of that? I would maybe do another check on the patient, maybe do another lab report or whatever, right? Or maybe I let them stay for a few more days, but then it was for nothing, right? So there's definitely an opportunity cost here. On the other side, the false negatives, they are the ones which the model really gets wrong, right? So the model tells us they're not going to be readmitted, but then in reality they do. So this is where I want to reduce this, of course, as much as possible. And then we get our correct predictions, which are of course where we realize the value of this machine learning model. Now, no machine learning model is going to be perfect, right? So therefore, the question is the benefits of getting it right versus the not getting it right? Is it a good enough model? And that's something you can read directly from this table here. Other things that we can look at is, of course, how did our model use the input data? So which of the input variables were most important? And the nice thing is this screen here, right? You get that very, very quickly. After 15, 20 minutes, you're being presented with the screen. And we see, you know, what are the most important drivers for making good predictions? And here, maybe not surprisingly, the number of inpatient visits, how many times a patient has been to the hospital before, seems to be one of the main drivers. Also things like the medical specialty, how many lab procedures, etc., etc. And then I can dig further in, right? So we talk about finding patterns in our data. I can have actually visualize those patterns. So here we see the number of inpatient visits was important, of course, but now what about it, right? Like, why are they important? And here we see the relative risk of a readmission, of course, goes up with higher number of inpatient visits, but it kind of tails off very quickly. So between 0, 1, and 2, there seems to be a big raise, but then it almost doesn't matter anymore. Other things I can look at here is, for example, number of lab procedures, and this is where it gets interesting. So here we see with maybe, again, not surprisingly, right, higher number of these lab procedures, the risk of being readmitted kind of raises, and maybe there's nothing we can do about it, right? It might just be a more complex condition. But then what about this here, right? If I have only very few of these lab procedures, also my risk goes up. So this is potentially where I'm missing out on something, right? Where I may have missed one of the lab reports, and therefore I could maybe do one more in order to help my patient. So this is an actionable insight here to really look at that. And then, as we've seen already in our dashboard, we get explanations for every single prediction that we make. So here's just a few examples. Why are patients, why do they have a very high risk or very low risk here? And on the high risk, we see, again, our number of inpatient visits being high, but then also, patients being a bit heavy. But then, interestingly enough, on my low predictions, right, it says discharge disposition is expired. So this means this patient is actually dead, right? Now, do I need to make a prediction on patients that are sadly died? Probably not, right? Because they will not come back unless there's, maybe a zombie apocalypse. So this is where I can quickly also find errors in my data, right? As I said before, and I think as my previous speaker also said, the data quality is a big issue. And sometimes we find these problems. Sometimes they hide very well. And having tools like this will very quickly tell you, again, you get to the screen very, very quickly. I will quickly tell you, is there something in my data that I need to adjust, and maybe go back to my data setup, my data preparation part, and then iterate. And this iteration part, that's not going to go away, right, with machine learning, but hopefully it's more guided, and you will save a lot of time on going down a route which is almost destined to fail. And as a last quick insight I want to show you is the text data that we have in here, right? So text mining has also been important. We are fairly good at using NLP to make predictions in terms of categorization, for example. So here in this instance, we see, for example, the descriptions of our diagnosis, and we now see which are related to a higher risk in red or a lower risk in blue. And that can hopefully help us as well to understand what is actually going on in our data. But again, the data needs to be clean, right? So data cleansing is kind of orthogonal to machine learning, and it is very, very important to do this as well. Yeah. Okay, so now I'm almost done, right? The last thing I need to do is get this model into production so I can then feed it into my Power BI dashboard. So how do I do that? I hit the predict button here, and I now have a few different options. I can, for example, just take a new data set, maybe of all of my patients that I have today, put them into here, and so upload them and then download the predictions. I can, of course, integrate that with my databases, but maybe I want to get real-time predictions. So for that, I can also deploy my model here. And if I do that, what happens is that we take this model, we move it to a dedicated prediction instance, which is then able to make predictions on a kind of request level basis. They are very fast, right? You can make real-time predictions with these. And the nice thing about this is it's also monitored. And monitoring is, of course, so important, especially when the world changes so much as it does today. We want to know, like, is our data still okay, right? Can we still use it? Now, in this instance here, I haven't really done any predictions yet, right? I just deployed my model. So let me just, for the last 2 minutes, choose a deployment which is already running, and here you can see things like data drift, right? And what data drift shows us is the data that I see today different to the data that I used for training my models, right? Maybe because, you know, certain things have changed. And then for every single input variable, we see the higher up, this is here on the y-axis. In this instance, we look at temperature, for example. We see the differences. It is much colder today than it used to be in our training data, right? So maybe this is something I need to care about. Luckily, this feature in this instance isn't very important, so maybe it is okay, right? So this is just a few things I wanted to show you here, how to get from the raw data that we have seen here, right, to a productionized model, which I can now feed back into my dashboard in order to get real-time predictions on my patients and see are they going to be readmitted or not. So with that, I'm going to close my presentation. Thank you very much for the attention, and I'm sure we have some time for questions.
Thank you so much, Lucas. We've got a couple of minutes left for questions. And I just spotted a couple in the chat that I'll pick up. There are quite a few questions in the chat, and I don't think we'll get to them all. So perhaps we can send those across to you and you can answer those for us later on. There was a question about how the models deal with missing values.
Yeah, that is a good question. So this is dealt with in the blueprints, and there's different strategies that we try actually. So sometimes it depends also on the model type, on the machine learning model type. Sometimes it makes more sense to say, for example, compute the median value that you've seen in the past. Sometimes it makes more sense to fill in like a very negative number, like -1 million, right? It depends, and we have different ways to try ways to kind of fill out these values. Yeah.
Lovely, thank you. And I think you mentioned during your presentation that you were switching between 2 different clouds. So we've had a question about if we're using your solution, does the data stay locally on users' machines, or is it processed elsewhere?
Right, so we have a software as a service solution, which is based in the EU, but we can also deploy on your own hardware, on your virtual private cloud, right? So we are very flexible when it comes to installing the modeling part of it, and then even more flexible when it comes to deploying models, right? So you can take the models out of the whole platform and then deploy that in a completely different space. If you want to have your model running in a hospital or maybe on a device, for example, right? That is possible, yeah.
Super, thank you very much. If I could just invite you all to give Lucas a virtual round of applause. Another great presentation, so thank you very much.
Yeah, thank you.
Thank you. So great start to the conference this morning. 2 really interesting presentations. I think we've all probably found ourselves in Excel hell, haven't we, at some point during our careers, or probably earlier this morning for some of us, I think, with some of the sit reps that a lot of us are sending in. It's great to hear about sort of the commonality around some of the challenges and hear about some real world problems that solutions like these can help us with. So really interesting and food for thought. So we're about to move into our coffee breaks. So if you grab yourselves a cup of coffee and then we're going to post the links again for the chat rooms and they'll go in the meeting chat. So we've got 3 different topics. So one on R, we've got one around machine learning, and then one on professionalism.